Okay, we will move to okay, we will move to next question. Okay. So we have done this one. Okay. So we will try to evaluate this kind of function. Okay. Xt is equal to e to the power j omega naught t. Okay. So we have xt. Okay. So we have xt that is equal to e to the power j omega naught t. Okay. So here we have the function. Okay. So here we have the function xt, and we are asked to find the Fourier transform. That is, we are asked to find the capital X omega. That is Fourier transform. No? So here, if you are use the first principle, okay, so you will get this kind of function j omega naught t e j omega t dt. Okay. So you should note that this omega naught is a constant. Okay, this is a constant. But here, this omega is not a constant; it is a variable. Okay, and here t is also a variable. But if when we are consider it in with respect to t, okay, t vision balanakota, we will consider this omega as a constant. Okay, this omega as a constant. Okay, අපි මේක t විශයෙන් අනුකලනය කරනකොට මේ omega කියන එක constant එකක් විදිහට අපි සලකනවා. but ඒක ඇත්තටම variable constant එකක් නෙවෙයි, ඒක variable එකක් නේ. time domain එකට frequency domain එකට හරවපුවම ඒක variable. So you get that idea. Okay, so previously we have seen that this evaluation is not easy. The integration is easy, but when we apply the limits, we can't get the finite value. Okay, so we can't evaluate this integral directly. Okay, it is hard to evaluate this integral directly. Okay, so let's try to use some property. Okay, so one property is there. Okay, time shifting property. Okay, I think you can remember this time shifting property. Okay, here it said that if you have a Fourier transform of xt as x omega, so if you get the Fourier transform of this xt, you will have x omega. If you have the time shifted of this signal x t minus t naught, okay, so this kind of signal, so this is a shifted version of this xt. Okay, so time shifted signal here. So you can get the Fourier transform as 2.5 x, sorry, this duality property. We will have e to the power minus j omega t naught. Okay, this t naught, this t naught, this x omega. Okay, so this omega is a variable, and here if you find this Fourier transform of this xt, here you will get the omega domain signal, frequency domain signal. So omega is a variable, or here also the omega is the independent variable. So you will get the function with independent variable omega. Okay, so here independent the Independent variable is omega. For this function, independent variable is omega. Okay. So this is the time shifting property. So you have a signal xt, then you will get the Fourier transform of ft, then x omega, you will get x omega as a Fourier transform of, as the Fourier transform of this xt signal. Okay, then if you get the time shifted signal x t minus t naught, you will get e to the power minus j omega t naught. Here omega is a variable. This variable, this omega and this omega is same, the independent variable, and t naught, you will get t naught, and it is multiplied by x omega. Okay, so this is the time shifting property. Okay, so now can you see? Now can you see? Okay, sorry, I'm sorry. Okay, so I will explain it again. Okay, so now we are going to, I will get a new page. Okay, so we are going to evaluate this signal. This signal. Okay, so we are asked to find the Fourier transform of this signal xt. That means we are asked to find x omega. Okay, so you have seen that when we are using the principal approach, that is xt here, we have e to the power j omega naught t and e to the power j omega t dt. Okay, minus infinity to plus infinity. So this is the definition of Fourier transform principal approach. Okay, so you can easily do this integration, but when you apply the limits, you can't directly get the value, get the appropriate value to this integration with limits. Okay, so it is hard to evaluate this signal using the first principle. So we will try to apply some properties to evaluate this signal also. Okay, so I am going to apply time shifting property. Okay, time shifting property. I will tell why I want, why I thought of applying time shifting property for this signal. Okay, so before that, I think I will remind you the property. Okay, so the time shifting property, uh, in time shifting property, if it is said that if we have a time domain signal xt and if we get the Fourier transform of xt, okay, so we will have x omega. Okay, so if we get the shifted time signal by t naught, okay, and you will get the Fourier transform of this shifted signal. So you no need to go through the principal approach to evaluate this signal, Fourier transform of this signal. Okay, you no need to go through the principal approach. Okay, this approach. Okay, you can directly get it using the time shifting property. Time shifting property said that this Fourier transform of this signal, this shifted signal x t minus t naught is equal to e j omega naught t, sorry, omega t naught, here it is minus, by x omega. Okay, so what you have to do, you have simply simply multiply this the answer of this xt Fourier transform of xd by this term, okay, e to the power minus j omega naught t. Okay, so if you have a so we know that for delta t Fourier transform is 1. Okay, so this is the Fourier transform of 1. So if you get the delta t minus t naught, so what is the Fourier transform? Okay, so in time shifting property said that, no? Okay, shifted signal shifted signal xt xt minus t naught, okay, xt minus t naught xt minus t naught. Okay, so what is the Fourier transform? The x omega you can simply multiply it by e to the power j minus j omega naught t. Sorry, omega t naught. Okay, so here also omega is not a constant. Okay, omega is a independent variable here. This same, this omega and this omega is same, and t naught is a constant. It is the shifted time. So you know that here x omega is 1. So you can simply multiply that by e to the power minus j omega t naught. So you will get this answer as the answer. Okay. Now if you consider this signal, xt is equal to e to the power minus j omega t naught. It is omega t, no? So I'm sorry, we can't use the time shifting property to evaluate this. Okay, we have to use the frequency shifting property. Okay, I'm sorry. අපිට මේක පාවිච්චි කරන්න බෑ මේ time shifting property එක. අපිට වෙන්නේ frequency shifting property එක පාවිච්චි කරන්න. හරි? දැන් මේ ටික මම හිතනවා කට්ටියට පැහැදිලි වෙන්නේ නැති කියලා මම මේ time shifting property එක ගැන පොඩ්ඩක් explain කරේ. එතකොට අපි frequency shifting property එකෙන් මේක evaluate කරන්න බලමු. හරි? sorry පොඩ්ඩක් වැරදි. එතකොට frequency shifting property එකත් මම හිතන්නේ ડોක්ටර් උදේශ් කරා example උත් කරා එකක් දෙකක්. Okay, so we will see what is the frequency shifting property. Okay, so you should understand that. So here it is xt is equal to e to the power minus j omega t. Okay, but in time shifting property we can have we will see e to the power j omega naught, sorry, omega naught t. Here we will see in time shifting property we can see the terms e to the power j omega t naught. So this term and this term is not equal, because here this omega naught is the constant and t is the variable. But for these terms, omega is the variable, okay, and t naught is the constant. Okay, හරි තේරුණානේ? දැන් අපිට තියෙන්නේ evaluate කරන්න xt සමානයි e to the power minus j omega naught t කියන function එක. හරිද? දැන් අපි time shifting property එක ගත්තොත් එයාගේ තියෙන්නේ e to the power minus j omega t naught කියන term එක. එතකොට මේ term එකයි මේ term එකයි සමානයිද? මේ දෙක සමාන නැහැ. මෙතන omega naught කියන්නේ constant එකක්. t කියන්නේ variable එක. හරි? මෙයාගේ omega කියන්නේ variable එක, t naught කියන්නේ constant එක. එතකොට මෙයයි මෙයයි සමාන නැහැ. එතකොට අපිට හිතන්න පුළුවන් මෙතෙන්ට time shifting එක පාවිච්චි කරන්න බෑ කියලා. හරි අපි නිකන් frequency shifting එක බලමු. So we will see the frequency shifting again. Hari. So we will see the frequency shifting. So we have in frequency shifting property, it is said that if you have a signal xt and Fourier transform of this signal, xt signal is x omega, capital X omega, then if you have another signal that have e to the power j omega naught t with and multiplied with xt, this kind of frequency time domain signal. So this is a time domain signal, no? Time domain signal. This omega naught is a constant and this t is a variable and this t also a variable, and then this t and this t is same. Okay, so this is the independent variable, and here also it is an independent variable. Okay, so this is a time domain signal. Okay, but that signal is this signal is multiplied by this terms e to the power j omega naught t terms. Okay, so you will get the resulted signal. Okay, so this Fourier transform, so you will get the frequency shifted version of this Fourier transform signal, that is omega minus omega naught. Okay, so this is the frequency shifting property. So this is the frequency shifting property. Right, now you can see we have xt. Okay, so we have xt. So if you are getting confused, okay, I will use this as ft. Okay, so here ft and here capital F omega, and ft we find time domain signal ft, and you will get f omega omega naught. Okay, so here xt and xt, sometime you will get confused. That is why I changed the letter x and f, x to the f. Not much a big change. Okay, I just change the letter of the function. Okay, so here we have xt is equal to e to the power minus j omega naught t. Okay, so we have this signal. Okay, so we have this signal. Okay, so now you can see that we are given, so this is the signal we have given. Okay, so we try to evaluate the signal using the first principle, but it is not easy. Actually, it is very hard to evaluate the limits. So we have to look the another way. We have to look for another way to evaluate the Fourier transform. So here we have e to the power minus j omega naught t terms. Okay, here we have minus j omega naught t terms, and in frequency shifting property also this term is available, no? E to the power minus j omega naught t, this term is available. So I can think of using frequency shifting property. Sometime I will be able to find the answer. Okay, so then we will come to the frequency shifting property again. Frequency shifting property. Okay. So it is in frequency shifting property, it is said that e to the power j omega naught t xt is equal to x omega omega naught. Okay, so in frequency shifting property, this term should be multiplied by the xt. Okay, So here extreme, so we will get this ft as ft. Okay, this is f, otherwise you will get confused. So another function. Okay, so here we have given the xt signal. Okay, and if this signal xt signal is a form of e to the power j omega t ft in this form. Okay, so you can use, and if you know the ft Fourier transform of this ft, you can evaluate this integral, no? So in this case, what is the ft? In this case, what is the ft? So ft is equal to 1, no? So in this case, ft is equal to 1. And you know the Fourier transform of 1, that is delta, no? Delta omega. So this is the Fourier transform of 1. We have found it just now. Okay, for 1, the delta omega is the Fourier transform. So if you consider this signal, xt is equal to e to the power minus j omega naught t 1. Okay, so this is the ft. Okay, okay. So if you get the, and you know this ft Fourier transform, that is delta omega. Okay, then you will get, okay, this Fourier transform f omega minus omega naught, no? So here f omega means delta omega, so you will get delta omega minus omega naught, correct? Okay, did you understand this? Sorry, here it is minus, so in frequency shifting property, here you have plus value. Okay, so you should do this plus, and this minus omega you can get minus. Okay, so this omega naught you can get minus, so here you have minus omega naught. Okay, so minus omega naught means, okay, minus omega naught. Okay, so you will get delta omega plus omega naught. Okay, so that is the answer. Okay, so we use frequency shifting property to evaluate this integral, no? So do you have any question? Did you understand this? මේක තේරුණාද ඔකට? මේක මම අර ඔකට හිතපු හැටි කිය මෙතන xt වල ටර්ම් එකක් තියෙනවා. xt කියලා අපිට දීලා තියෙනවා e to the power minus j omega naught t. දැන් මේ වගේ ටර්ම් එකක් තියෙනවා frequency shifting property එකේ. හරි? මේක දැන් අපිට එකක් තමයි මේක අපිට කෙලින්ම evaluate කරන්න බෑ. හරි? එහෙමනම් අපි වෙන විදිහක් බලන්න ඕන. දැන් වෙන විදිහක් බලනකොට අපිට frequency shifting property එක මතක තියෙනවා නම් ඒවා use කරලා ගණන් හදන්නත් පුළුවන් කියලා දන්නවනම් අපිට සමහරට මතක් වෙන්න පුළුවන්. හරි, මේ වගේ ටර්ම් එකක් අර frequency shifting property එකේ තියෙනවා. එහෙනම් මේ frequency shifting property එක use කරන්න පුළුවන් වේද කියලා බලන්න පුළුවන් try එකක් දෙන්න. නේ? ඊට පස්සේ අපි මේක ලියා ගන්න ඕන frequency shifting property එක විදිහට. හරි? එහෙම ලියාගත්තාම මෙතන ft වෙන්නේ එකක්. ft වලට එනවා එකක්. හරි? එතකොට එයාට එක දැම්මොත් එහෙම අපිට එනවා frequency property එක. අපි දන්නවා එකේ Fourier transform එක අපි දන්නවා. ඒ delta omega. අපි ඒක ඊට කලින් හෙව්වා. නේ? එහෙනම් මෙතන xt කියන එක අපිට ලියා ගන්න පුළුවන් e to the power. හරි, xt කියන එක අපිට ලියා ගන්න පුළුවන්. xt කියන එක අපිට ලියා ගන්න පුළුවන් e to the power minus j omega naught t එක කියලා. හරි. ඒකම අපිට ලියා ගන්න පුළුවන් j minus omega naught t එක කියලා. අපි දන්නවා මෙයාගේ Fourier transform එක ඒක delta omega. හරි. impulse function එකේ නේ unit impulse function එක omega domain එකේ. හරි. ඒ කියන්නේ ඔමෙගාත් එක්ක තමයි එයාගේ යන්නේ. මේක එයාගේ function එක. ඒක තමයි delta omega. හරි. ඒකට අපි දන්නා මේ function එක. ඊට පස්සේ අපි එකේ Fourier transform එක. එහෙනම් මේ e to the power minus j omega naught t වල එන්නේ මෙතන මේ function එකේ t වල frequency shift inversion එකනේ. ඒ කියන්නේ එතන ft තිබ්බනම් අපිට ඉන්නේ capital F omega minus omega naught. දැන් ඇත්තට මෙතන තියෙන්නේ delta. හරි. දැන් එතන ඇත්තටම තියෙන්නේ delta. දැන් මෙතන ඇත්තටම තියෙන්නේ delta. එහෙනම් අපිට එන්න ඕන delta omega minus omega naught. හරි. ඒකට delta omega minus මෙතන minus omega naught තියෙන්නේ minus omega naught වෙනවා. ඒකට එනවා delta omega plus omega naught. ඒ කියන්නේ අපිට එන්නේ මේක omega නම් මේක delta omega minus omega naught නම් මෙන්න මෙතන plus omega naught නම් මෙතන එන්නේ minus omega naught. මේක තමයි අපි දෙන උත්තර. හරි. frequency shifter. මේ පැත්තේ තියෙන මෙතන 0 වල තියෙන එක plus omega naught නේ. minus omega naught නම් මේ පැත්තට shift වෙන්නේ omega naught වෙලා. හැබැයි plus omega naught ඉඳලා මේක මේ ඍණ පැත්තට shift වෙන්නේ. එතකොට එතන යනවා minus omega naught. එතකොට මෙන්න මේ වගේ එකක් තමයි ඉන්නේ අපිට. නේ? minus omega naught වල මෙන්න මේ වගේ function එක. එතකොට මේක shifted unit impulse function එක. හරි. ඔකට තේරුණාද? අපි ඊළඟ ගාන බැලුවොත් එහෙම ඊළඟ ගානත් sorry මම මේක හදලා තියෙන්නේ. ඒකට ඊළඟ ගාන මේක ඔකට තේරෙනවා. So if we get xt as e to the power plus j omega naught t. හරි. ඒතර මේකත් එක කියලා ගත්ත හැකි. මෙතන ඒ කියන්නේ delta omega. හරි. එහෙනම් මෙතන එන්නේ delta omega minus omega naught. එතකොට ඒක එන්නේ මේ වගේ සිග්නල් එකක්. delta omega minus omega naught. හරි. අපි තව ගානක් හදනවද නැත්නම් ඔකට වෙන මොනවා හරි ප්‍රශ්න තියෙනවද? තියෙනවා නම් අහන්න පුළුවන්. අපි නම් තව ගානක් හදමු. මම ගණන් ආය බැලුවේ නැහැ පොඩ්ඩක් ඉන්න බලන්න ගානක් දැන් බලන්න මම ගානක් බලන්න.